Hello, good afternoon and
Hello.
good evening, everyone. Welcome back to another session of HashiCorp User Group Sydney. And my name is Ben. You've probably seen me in some of the previous sessions. And today I'm joined by Vrukshali. Vrukshali, could you introduce yourself?
Hello everyone. This is Rukshali. I am a student pursuing a bachelor's in engineering in India, and also I am a Red Hat certified engineer automation with Ansible, and also a Red Hat certified specialist for Kubernetes and OpenShift stuff. And also, I am very passionate about open source. Yeah, just dived into it. And that's pretty much about myself.
Great. Thank you very much for joining us today, Vrukshali. Um, Back to what we were, the purpose of today's talk. It's about the Terraform certification program. So I'm just going to share a screen for now. Now, we have been running this Terraform mentoring program for, I believe it's 2 weeks or so now.
Yeah.
This is something that Brad McCoy has set up, and it's actually on a GitHub. If you look for Brad McCoy dev/mentoring, you will find that he has this mentoring program for a variety of different projects, I suppose. There's KCNA, there's Terraform, there's GitOps, and this is specifically the Terraform program. Now, we have ran a couple of these sessions, as I mentioned before. This is the next one where it's about understanding Terraform basics. So, what exactly is the purpose of this? The end goal of this project is that anyone that goes through this mentoring program will get the Terraform Associate cert at the end of it. So, we're going to be guiding you along the path on and teaching you the basics of how to use Terraform from an entry level to more and more advanced as you go along. And this is the results of your hard work at the end of it. Now, throughout this particular course, we do actually have a few exam vouchers from HashiCorp for people that participate in this program to be able to win the certifications. Well, not certification; they win the voucher in order to take the exam, which is worth 70 USD. So at the end of today's session, we'll be announcing two people who have won the vouchers for this session. And for this week, what we'll be going through again is the section Understand Terraform Basics. Now, if you're on this website, you'll be able to find quite a few handy tips. Let me just bring that up. So that's the website for it. If you go in there and go under the review guide, you'll see it actually gets quite detailed in terms of in each chapter what exactly you're expected to know and what would be very handy for you to pass the exam. So as a starter, let's go through understanding Terraform basics and provider installation and versioning. Vikshali, have you been using providers much in Terraform?
Yeah, I have been using like AWS providers much.
Mhm.
uh, and like before starting, I will tell like the installation procedure provided by the HashiCorp Terraform itself is really good. Like you can find everything, manual installation as well as the direct CLI installation. They have explained it very well for like all the operating systems, Windows, Linux, Mac. So just have a look at that video.
So
Yeah,
yeah,
this
like
one.
regards you mentioned, it's actually really straightforward with
Yeah.
Mac. It's literally just install. Windows, similar thing, Choco install. Linux was a bit of a strange one that it actually goes through more steps. What what I've been using thus far with Linux is that we actually just download the binary itself
Yeah.
and extract it to path. That felt like a simpler way than all the
Yeah,
steps,
simpler
but
way. Yeah.
as long as it works, you get Terraform out of the box out just like that. So yeah, that's in a nutshell how to install Terraform. It's yeah, like what Charlie said, super easy. For the most part, for Mac or Windows, it's just like a one-liner. Now, now that you've got Terraform installed, what you should get then is, well, in your terminal, if you bring your terminal up, one sec, you will just be able to run Terraform. That will just tell you, well, Terraform's running. Obviously, if your installation failed, that's not going to work, but that's in a nutshell what you're supposed to get after the installation is done. Now that we've got Terraform installed, what's the next step? So, Victoria, you had mentioned you using AWS as provider. Um, Personally, I've been using Azure mostly for what I do, but the benefits of Terraform is that it's a common language that's used regardless whether you're deploying AWS infrastructure or Azure or even anything on GCP. The language is the same. All you need to do is understand the documentation and how exactly you're supposed to write the parameters that you're supposed to pass in to create cloud resources. So as a start, let's look through what providers are actually available. Now that's straight up on registry terraform.com, which is that. Or if you just search Terraform registry, you'll just get this. Now, as I mentioned, you get all your major cloud platforms: AWS, Azure, GCP. That's your typical providers, and you do have a lot of other ones like Active Directory, the Azure Active Directory. There's null resource and a whole bunch of other quite useful ones that, depending on your scenarios, you may or may not use them.
Mhm.
Share something to that, Chen?
Oh yes, just one thing. So means those who are beginners, the Terraform documentation is really excellent. Like I just love the documentation done by them. Like it's very easy. You can just need to just understand the code, and everything is explained in detail below. Like you can have
Mhm.
a look at the documentation as well.
Perhaps we could start with an example. Virtually name any specific resource that we can just go into,
Like
and
you
we'll
can
show.
like AWS EC2 instance,
Mhm.
AWS EC2
Yep.
instance.
So as the first step, once you get into AWS, in order to even start using it, they straight up give click on that, and that's all you pass in. You
Yeah.
specify the AWS and the version, and when you want an EC2, just search in there, EC2 instance, EC2, EC2. Which one's the EC2 instance again? Is it a host?
No, no, no. It's EC2
It's actually
instance.
called instance, is it? Let's see, instance. There you go.
Yes.
AWS EC2 instance. There you go. So there you go. It's quite straight up just that.
Yes.
It gives you all everything you need to deploy it. You just use this documentation, and from there, you scroll down. It tells you what exactly it expects. Like in this case, AMI is an optional feature, and it'll tell you which ones are optional and which ones are required. Almost everything is optional in here. So yeah, it tells you in a way like it's expecting a parameter called source destination check, and what exactly you're supposed to pass it through. And a
Yeah.
lot of these you'll just be able to look at one of these examples and be able to tell, all right, that's supposed to be instance type of T2 micro, and there's a network interface block of all these extra parameters. So documentation wise, they're actually quite straightforward. And just to compare, let's show, let me just bring another one up. Sure. All right, so EC2 is basically a virtual machine. I'll show you what's the equivalent in Azure. Virtual machine. So there you go. This is an Azure virtual machine. When you look at the format, it's still the same thing: resource provider, the name that you give it,
Yeah.
compared to in Amazon. It's the same thing:
AWS.
resource, AWS, and that. Now, one thing that is quite useful to remember is this underscore here. That is very deliberate on Terraform's part. Whatever is before the first underscore, that is what it retrieves as the provider. In this case,
Provider.
AWS, it'll know to retrieve provider AWS. And same thing for Azure, but right before the first underscore, Azure RM. That is how it knows which provider to use to deploy a specific resource. Now, we have some examples. Oh, I've got an example of an Azure project that I've been working on, and it shows how you can integrate multiple providers in one project. That's quite useful, I guess. Let's go to some code snippet. Now, just as a quick explanation here, Terraform required providers. This is where you just list down what providers you're using. In this case, I'm using Azure RM for an Azure provider. and there's a random provider as well. Random, let me just go back to the docs and show you what random actually does. It's quite a handy tool that we use for creating secrets. Again, this is just another provider, no different from AWS or GCP or Azure. What it is you start something with a random underscore. Again, what I said before, whatever is before that specific underscore, that is what the provider is. And we use that to generate random passwords. Or you can use, in this next example that I'm going to show you, I'm using random UUID. It This random thing is one that we actually use very frequently, purely because it's a really simple, lightweight provider that gives us a lot of value. I'm sorry, that Atharv, I'll answer your question after this part. So, random is something that we use quite often. Random string, for example, that when you have resources that need to be that need to have a globally unique name, like say a storage account in Azure or a Key Vault or various other resources, what we sometimes do is we add a random string suffix to it, so we can call our resource, let's just say HashiCorp demo Sydney. I can use that the first time around, but if I need to create multiple things of that same HashiCorp user group Sydney name, I will need to append something at the end. And random string, this is something that is quite useful to just generate like a four character long random suffix that you just attach to the end to make something globally unique. And in this case, what we're doing is we're using that same random provider in here. And what we do is we're just doing a random UUID and we're generating API keys. Now, this code might look a bit complex right now because it's got quite a few things going on, but essentially this is how we use a random provider with an Azure provider. What I'm doing is I'm taking the result of this random thing and passing it in as an input for the password stream. So going back to here, if we go back to the registry, there are just many ways that you can integrate multiple providers to do the same thing. So like, for instance, if you wanted to integrate AWS with Azure, again, you can deploy different resources in one cloud provider and another resource in the other. And you can just take the outputs of that to combine them in, well, sky's the limit here, actually. You can just do whatever you want with it. Now, before we go too far on, Atharv had a question. Just putting that on screen. What would be the best cert for beginners who are trying to learn cloud? AWS Cloud Practitioner or Terraform? Very good question. Any comments, Charlie?
Yeah, so for learning Terraform, you must have the knowledge of cloud, right? So then, like Terraform is used for like provisioning the infrastructure in the cloud side. So you must have first learn the cloud like AWS, Azure, whatever you may feel like, and then you can jump to like Terraform and stuff. So I guess AWS Cloud Practitioner will be the first cert for the beginners.
Fully agree. So, like what Charlie had said, if Terraform is purely just deploying the resources, so if you didn't know what an AWS instance is, well, Terraform's not really going to help you there. You'd be looking at AMI, an instance type, and thinking, I don't know what these values are supposed to be. Whereas if you had the knowledge in AWS before, for example, I work in Azure, so when I'm looking at instance type T3 micro, I have no idea what that is. I don't know what I'm supposed to actually pass into it. So when you have the knowledge into it, then, and it doesn't really matter which cloud provider you go for, actually, because a lot of the knowledge is quite transferable. Like, for instance, in my mind, when I'm thinking I want to deploy a virtual machine in AWS, what I do is virtual machine AWS, just look that up and it'll tell me EC2 instance. Um, One thing that I had found a bit peculiar about AWS is that it doesn't name things as what it is. Like an EC2 instance, I think, what's that supposed to be?
Oh
And
yeah.
AWS Lambda is a function. So
Huh.
AWS has more of a proprietary name for a lot of their
Mm.
resources, which, I mean, the moment you know what it is, then it's easy. But when you're
Yep.
starting out from scratch, you might go, what is a Lambda? So yeah, any thoughts on that, virtually? Or
So we can
okay.
continue.
Yeah. So yeah, I hope that answered your question, Atharv. So as we continue, so going back into not getting sidetracked, so we've covered providers, we've covered installing Terraform, locking and upgrade provider versions. That is quite a key, quite a useful feature, I suppose. Now, back when we were just looking at providers before, like say this AWS thing, remember when I clicked on this use provider thing and it showed AWS HashiCorp version 3.4, 3.74.0? This is exactly how you pin to a specific version. Now, I know that Azure itself does have a very frequent release schedule. I believe they do every fortnight or so, they increment another version. And there have been instances where um, their new version has just added new functionalities or broke things. And that's why it's useful to pin it to a specific version like that. So you can do a whole bunch of different options like this is specifically 3.74.0, and you could also do in here, um, I believe it's something along the lines of this. You might have to double check where it involves this tilde sign, and it will take in anything that's 2.940. It takes in 2.941. It takes in 2.942. It's all okay, but the moment it goes to 2.95, then it will not bump up the version. You could always, well, the moment you run Terraform, what it does, it creates a Terraform log file. That way, it says that whenever you run Terraform again, make sure that your version is specifically this or whichever greater, greater equal like that. If you have any of these version constraints in there, that will ensure that whenever the provider does bump up a few versions or have new releases, it doesn't actually cause any conflict. So version pinning, very useful, especially when some providers are a bit more gung ho than others in releasing things. Scenarios where you wouldn't use this version pinning, there are some instances where there are resources like the Kubernetes provider, not Kubernetes, like the Azure's Kubernetes resource. Kubernetes is something that's growing so quickly that about maybe every fortnight, every month, there's new features being added, and that's when you would want to increment your version and make it so that you make sure you've got the latest and greatest features. Because using this as an example, if you look at this, it says 3.74. All right, so AWS actually does have a weekly release cadence as well, as you can see here, every a day, 8:15. So it moves so quickly that it just bumps a major number, and that could be good, could be bad. So looking at some of these, like if you went and used one that's a month old, there could be new features that are added that's well, just makes it a bit more complicated, I suppose. So, all right, so where were we? Locking and upgrading provider versions. Now, upgrading, that is something that, if we go back to Terraform again, now I have written in here that I want a specific version. This version is actually an optional parameter. So apparently that's the syntax for accepting a minor version, the tilde and the greater sign. Now, what happens if we take those out? It will still run just fine. That just means that it will always get the latest version just for the first time. And once it does it, it saves it into the Terraform log file, and then it won't bump up beyond what's written here. But if you ever do want to force it to increment a version, what you can then do is Terraform init -upgrade. Now, adding the upgrade flag in there signifies that you want Terraform to obviously upgrade a version. So it will then look through your Terraform thing. Like in this case, my required providers, I did not specify any version constraint. Therefore, it will just bump it up to, say, 2.95 or 2.96, whichever it is. Whereas if I had done, say, It's loading. So with that, if I if I had written this, what it will do is it will try and get the latest version that matches this version constraint. So it could be 2.94.99, for example, and it'll just get the very latest of the 2.94 series and not the 2.95. So that's how you upgrade provider versions if necessary. All right, so that's how we upgrade provider versions. Plugin based architecture. So this is very much talking about, well, what we had been speaking about before with the different providers. How they define this is that you could sort of swap in and use Azure in some instances, AWS in other instances, and you just it's quite compatible in the language. Obviously, writing an EC2 instance against an Azure virtual machine, it's expecting completely different parameters. So even though they are thinking that they want something to be very much a plug and play thing, it in reality it's not as smooth as that. If only. That would be very nice. So going back into here, lock and upgrade provider versions. Again, that's stuff that we had covered. Describe how Terraform finds and fetches providers. Now, this is something that's also quite interesting because here in the Terraform registry, this what you see in this front page, these are the official HashiCorp. It's sort of the equivalent of the Twitter blue tick or your Instagram verified thing. These are the official ones, and there are a whole bunch of others that, let's just say, for example, the popular DNS provider GoDaddy. Still find that a really weird name, but all these are um, user created providers. For example, this one, M3. So to do that, you would have to specify the source. Now, when you're using an official Terraform approved provider, for example, you can just write the source. You don't actually even need to specify the source in here. I could just take all of that out, and Terraform would run just fine, because Terraform knows that this thing random UUID, it knows that it's an official Terraform approved package. Whereas with stuff like this, like say GoDaddy, where it doesn't have the official yellow medal, you would then need to actually specify that anything that starts with a GoDaddy underscore, that will need to be pulled from this specific source, entry integrations / GoDaddy. And this, as you can see here, if I did the GoDaddy again, you'll see that there are various users that have created different versions of the GoDaddy DNS provider. All it does in here is you're just creating CNAME A records, text records. It's quite standard behavior, as you can see, GoDaddy underscore, and yeah, that's how you use it. It looks at the underscore, and it looks at the GoDaddy, and that's where it looks through the record providers of where exactly it's supposed to source it from. You would just have this kind of providers for various things. I personally have not ever gone to the extent of needing to deploy an official or deploy a package to Terraform itself, but that's something that after your certification, you've done quite a few things that you find is really useful. You can obviously just push one of your modules up into the Terraform registry to be used. Modules, I believe, is something that comes further down here. That's in 2 weeks' time where we talk about modules. That's when you would be more likely to be pushing stuff to the registry.
Mhm.
Have you got much experience working with modules, Charlie? We'll just touch over it briefly, just to explain how the Terraform registry is useful for certain scenarios.
I like Terraform registry means first you told about the modules, like we can create our own modules and push to the Terraform registry. It is like contributing to the community, like so that's one thing about that. Pretty.
Yeah, correct. Because there are a number of resources. Like right now, the examples that we had shown you before were quite um, standard. Let's see, top-down loaded AWS modules. I believe some of these might actually be user-created ones, but some of those resources, like say, if you're deploying a Kubernetes cluster, that would involve using a lot of additional things like in Azure, you create a resource group, you create a Kubernetes provider, you create subnets. There's for one resource you have a lot of dependencies, and that's when modules are useful where someone just bundles it and say, me as a user, as the end user can say, I want a Kubernetes cluster. I fill in details A, B, C, and D, and then you will take it away and deploy all that in the background. So I don't need to. It just abstracts away the complexity, and it's handled by one of these user-created modules. Okay, so we've got a comment from Kumar asking, what is the use of random provider? Very good question. Random provider is one of my favorite providers. Let's just give that another whirl. Okay, docs. So random provider, it literally just does random things. If it does, it creates ID, creates passwords, creates strings, UUID. Now, the thing that I use the most in the random provider is actually just random password, because like in this example, it's creating an AWS database with a username and a password. Now, if you were to generate a password yourself, I don't know, you could do a few things. You could just type in Google and say random password generator, click generate a few times and copy and paste that in. That's manual, that's clicky, not so great. Whereas if you use a random password resource like this, you just specify it needs to be 16 characters long. You can, let's see, I believe there's optional. There you go. You can say that it needs to have lowercase, it needs to have uppercase, it needs numbers. So your typical maximum security type password, alphanumeric, uppercase, lowercase, includes special characters like that. That way you can generate a password that's 16 long, 32 long as you want. And no human ever needs to see it. No one ever needs to copy and save it to their desktop. It's just generated there and passed into the database. So that way there's just, well, there's no need for you to see the password because you shouldn't be seeing the password anyway. That's one example of how we use random password. The other example is the random string, which I had mentioned before. That was to just generate a random suffix. And this here was the example of how I'm actually using random UUID to create an API key. Because API key wise, in this case, we wanted it to be a specific format of a UUID. So this is how we're doing it. You create a primary key, and you don't actually even need to pass any parameters in here. Just UUID primary key, and I'm creating a key vault or the equivalent in AWS, which is secret store or secret management store, something along those lines. All you're doing is you generate a key and immediately pass that into your secret store. No one needs to know what the value is. Your app, if it requires access to the key, you'll just retrieve the value straight from the secret store, and it just works like that. So that's one of the most useful parts of the random provider. Random pat's a bit random. I think you might get like a Toby or a Bob or whatever you would call your pet. I think this was just Hashiko playing around. But the rest of it, you know, you use it as you see fit. Random integer just gives you a number. So for the most part, I just use random password. That's my take on the random provider. All right, let's go back to our guide. And where were we? So we were talking about plugin based architecture, multiple providers, finds and fetches provider. Okay, Kumar's asking, secret that I'm generated is permanent. Am I right? Yes, you are. So going back to the random password thing, there's something called keepers. What this means is that um, when you generate a password, it it stays as a password for until you decide to recreate it. So just use this as an example. Okay, so if I were to just comment everything out, hold on. Okay, live demo. I hope nothing goes wrong. Validate. Okay, it is unhappy. outputs. Let me just get all of this stuff out of the way. Okay, configuration is valid. Now, even though it's not actually asking for anything, I'm just going to send it through because there are variables in there. Should have used apply. Yes, I have created. So what I had just done was I've created two of these, a primary API key and a secondary API key. Now, if I go to Terraform console, Terraform console is actually a, I don't know if you guys can actually see it. All right, Terraform console. Oops, that might be a bit too big. Terraform console is quite a useful feature where you can test various Terraform stuff, I guess, Terraform functions. So what I'm going to do is random UID dot primary API key dot result. So this tells me that that particular key that was generated is this. So even if I ran Terraform apply 10 times, 20 times, that would not actually change. The only time this particular result would change is if I were to say apply, replace, and you specifically target that in random UID dot primary API key. Now that would get replaced, the result would shuffle, but in this case, I'm not going to do that. So once this is created, it's stored inside your secret store. It stays there until you do something like what I had just done with a replace, or alternatively, keepers is the other useful part where what this keepers does is it's a map of string where what I've been doing with keepers is it helps you with your password rotation. It's like say password created month equals it's something along the lines of this date something I can't remember the exact parameter off the top of my head. So if I did that and I specifically got the month, now in January, anytime you run Terraform apply, it's not going to change because the keeper still says password created month equals January. But the moment it flips over to February, it will detect that there's a mismatch now, something has changed in the keeper, so I will recreate this primary API key. And once that gets recreated, it will then trigger downstream that it knows that the value that I have passed into the secret store has changed, and therefore I will update that value. So Kumar's follow-up question, if you update your resource, you will lose access to your secret key. No, that secret key actually still stays in your Terraform state. So state list, it still sits in there. It's in your state file. It knows what the value is. If you update your resource, could you clarify what resource perhaps that you're referring to? Like say if this key vault, if you were to delete your key vault, then yes, you will no longer have access to the password, but Terraform still knows about it. So the next time you create a key vault and you specify this specific line, the one that I was typing before, random UID primary API key result, that will pass that value back in. And it's not going to affect, like in the example that we had seen in this random password. So it's not going to affect that your DB is still using the same password until you rotate it with the keepers thing that I mentioned before. Did that answer your question, Kumar? Cool. All right. Let's see. Any other questions in there? Prerequisite for learning Terraform. So that's something that Vrukshali had mentioned before. Like that sort of relates back to the question that we were answering before about learning AWS before Terraform, wasn't it? You need to know a bit of cloud in order to do Terraform, I suppose.
Yes, yes. Then how would we able to understand the keywords of Terraform if you don't know cloud?
Correct. Yeah. So going back to our schedule, provisioners. That is something that's a bit on the well, provisioners. HashiCorp itself says that it's a last result. Last resort. Vishali, do you know much about provisioners? Perhaps you would like to talk a bit about that?
Yeah, like after like we have created a resource on the cloud, right? So next we need to like provision like what we want inside that resource. Like we want like any software to be installed. So like provisioners are that helps us to do this work. Like you can also like use directly in the Terraform code, or you can also integrate it with like configuration management tools like Ansible, Chef, Puppet. So,
Perfect. Yeah, exactly what Vishali said. Just to add on from that, the reason why Terraform even has provisioners, even though they say please don't use provisioners, they recognize that there are things that Terraform isn't able to do, like using the virtual machine example that we've been using for the most part. The moment you provision a virtual machine, say for example, if you wanted to make sure that the virtual machine has Python installed for you to run specific uh, libraries or tests, anything of that sort, deploying a virtual machine does not mean that the virtual machine has Python installed in it. That's where you can use provisioners. There are two main provisioners that you use. One is called a local execute or local exec, so it just executes it locally on the runner, whoever you're using to run the Terraform code, and remote exec, where it's running on the target resource. So using this, using my PC as an example, local exec means I'm running a terminal on my computer saying echo hello world. Remote exec, on the other hand, it will echo hello world in that VM, not the VM that not what I'm using to run Terraform apply. So cloud init, that's something that is the equivalent of like an example of what I was just talking about before with the Python. You use remote exec to say I want to download this build tool or that specific dev tool. So those are the things that you would use provisioners for. It's sort of a bit debatable whether or not you want to do all these things because Terraform's main benefit is that it understands state. It knows that when I've created a virtual machine, I know that this particular address points to this virtual machine. And if there are any changes into it, say someone scaled the virtual machine up or down, Terraform will be able to pick up that change and say, you were expecting a VM with 8 gigs of memory. Someone hadn't gone into the portal and made it 16 gigs. So I will turn it back down to what you had actually specified. Now, with provisioners, that is something that it cannot manage because Terraform does not know that you've installed Python on the virtual machine. It does not have any way of going into the virtual machine and pinging, going Python dash dash version. Do I have Python or not? So that's why HashiCorp explicitly say, yes, we let you do it, but think about if there's a better way rather than relying on this provisioner. So it has its time and place. It's optional whether or not you use it. Now, you may get some questions in the exam about it. I took the exam some time ago. I don't actually remember, but it's essentially it boils down to understanding when provisioners are run. There are different scenarios where you can say the exec it can run it before the resource is deployed or after or even upon deletion. Like say using an example of a local exec of let's just say allowing the IP address of your virtual machine through a firewall. Now, if you were to destroy the virtual machine, obviously you would want to revoke that permission to put the IP address on an allow list. So that's when you could use a local exec that runs when the resource is destroyed. So when virtual machine ABC is decommissioned, make sure that its IP address of 1.1.1.1 is no longer on the allow list of our whichever of wherever. That's how you can use provisioners. That's a few scenarios where you potentially would have used provisioners before. But yeah, it's a tool. Use it wisely. Um, that actually, do you have anything to add to
Yeah, like
what
I
we've
have
spoken about? Yeah.
one question. Once what are like cloud init and that packers stuff? Like I
Mhm.
have gone through the documentation, but I didn't understood what actually it does.
Mhm. Let's go through that now. Let's see, cloud init. What is it doing? So it's doing cloud init, cd, create an SSH key, users, cloud init, script to the Terraform configuration. All right. What is it doing? So it's creating an EC2 instance. That's all standard Terraform thus far. Terraform init apply, verify that it exists, destroy. Where's the cloud init? In this tutorial, you configured an instance with cloud init. Where did that init part even come along? Mm, Keygen, cloud init, template YAML. What exactly does it do? I don't get this specific tutorial. Well, cloud init is one of those where you can actually use it to, um, say, when your virtual machine is ready, you would want to. It's similar to what I had mentioned with the install Python, but you use it for installing tools and other dependencies usually. What about Packer one? Let's see if that has a bit more examples. Packer, git clone, cd, ssh, show. There you go. That's more like it. This is what I was thinking that Cloud Init will be the similar thing you're doing. You're actually getting it to run a bash script to install curl, install a whole bunch of other um, required packages, programs, and yeah, this is how Cloud Init Packer. That's how it does. That's how it works. It basically just provisions your infrastructure the way you want it to be, and um, it could be used in some custom cases where, like, say, you want your virtual machine to be using a specific SSH key or given access to certain repos via an SSH key. That's when you can use these to pass it in. Okay, and this one, provisioner, provisioner. There you go. With file, you're specifying a file that it's going to copy from one location and pass it into the VM. This EC2 instance, I believe. Yes. And yeah, that's kind of how
Yeah.
provisioners work. All right. Let's see. Do we have any further questions? Best use case for Terraform. Well, do you want to take that one, Shannon?
Yeah, like best use case is like to uh, launch the resources on the cloud without means like without manual practices. Like if you want to launch the instance suppose 5 times, you won't go to the cloud and just say launch instance, just write the code and apply it. So this is the best use case of Terraform.
Yep. And here's a live example of how that would work. So let me just uncomment all that. Here's an example. We're creating just using the very first resource as an example. Name is local share primary name, which in this case is just project ID, location, environment. So if you're creating something that's, just say, in dev, in test, in prod, in 3 different environments, if you were to do this in the portal, you would go inside, like what Charlie said, click, click, click away, deploy. Once that's all done, go all the way back, click, 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 click all the way again. With Terraform, what you do is, as an example, what we have in here, we create the environments. You set the environment to test, you set the environment to prod, to UAT, anything along those lines, and then you just deploy Terraform and it will just get passed all the way through. And this works even when it's just one resource group, or you have a key vault in here. It's all taking the same shared primary name that automatically updates it from test to dev to prod to whichever environment it is. So it makes it very much scalable. If you have to deploy 10 resources in 3 environments, you are 100% certain that it's always the same spec that you go all the way through. And the further benefit of Terraform is that it maintains the state. So, for example, if you right, just use this as an example. In what we have done is we have put a budget amount on the resource group just so we can manage the cloud costs. So if we said that this resource group would send an alert when you exceed $100 spent this month, and someone cheekily went into the portal and said, "Ah, crap, I'm going to deploy a lot of stuff this month, so let me just sneakily bump that number up so no one's going to know." When Terraform runs, it will know and it will change it back, and that person's going to get in trouble. So that's how Terraform can be really helpful in managing your infrastructure. You run it periodically. You make sure that any changes that is happening is documented. So another big example is the SKU for most of our resources, like that T2 micro thing from the EC2 instance that we saw before in the AWS example. If it's T2, it's supposed to stay T2. We don't want it to be, say, a dev manually scaled it up during the testing phase and realize that, and when prod breaks, it's because prod wasn't on the right spec. So that's when using IAC, it's super handy that you know exactly what it's supposed to be and it stays that way. So that is what I find the best use case for Terraform. Let's see, do we have any other questions on anything in here? Or, well, actually, we sort of talked a bit about state, which was last week's topic. But yeah, that's basically what the perks of Terraform is. Do we have any further questions? Or any thoughts for Charlie on what we've
No,
been talking about so far?
no, nothing. It was great session. Learned a lot of things from you. Like, thank you.
Perfect.
Yeah,
So,
we have Brad as well in the chat. Like, hello, Brad.
Brad's joined in.
Yeah.
So I think I don't have anything further to add to this week's session. So if you have nothing else to add, we can announce the winners of our 2 certifications this week.
We have like one, like Shubham Chaudhary.
Yep.
Uh, just got to know that world-class companies like Uber, Udemy, Slack are using Terraform in their tech stack. Yeah.
Yes, Terraform is actually very useful. It's quite a useful tool, and in terms of the learning curve, it's if you know cloud, you would be able to do Terraform. Terraform itself isn't the hard part. It's more knowing the resource that you are trying to deploy. That's the tougher part. Terraform itself it kind of just looks like JSON. It's not. It's just something equals something. It's not really like a.
It's not really like
It's not
hard
complicated.
hard coding like something like in C++
Yeah,
or like it's very simple.
especially when you keep it simple like this. And there are things that you can do in Terraform, like say merge. You get more of these functions that you can learn about that can give you more benefits. But for the most part, Terraform isn't overly difficult to use.
Mm-hmm.
All right, so
Yeah.
without any further ado, we will
Let's.
announce the winners of the 2 certs. Congratulations to Sergio and Carol. I'm not
Yeah.
sure if you guys are on
Congratulations.
this. I'm not sure if the 2 of you are on this call, but congratulations. Reach out to Brad on the mentoring Slack, and he'll be able to get it sorted. So going back into here, let me just put that banner up. I wonder if I've got this. No, I don't. Okay, let me just copy paste that here. That might be a bit of a
Yeah.
handful for you to type. Actually, just search Brad McCoy Dev Mentoring, and that will
Yeah.
get you to it. So Um, Reach out to any one of us in this particular mentoring thing. There's a Slack channel that is set up. The moment you do a pull request into this mentoring repo, you will be able to. It'll have the link to join the Slack channel. So come join the mentoring channel. Put yourself under the contributors, I believe. Put
Yeah.
yourself in here, and you just do a PR, and you'll be able to join the community.
Mhm.
So, congratulations to the two of you, and I hope that everyone enjoyed this particular session. So,
Yeah.
thank you very much, Rakshali. It was a great
Thank you.
chat.
Yes, thank you.
All right, I'll see you all next week.
Bye.